for arriving. My name's Alex McFadyen. I'm the CTO of a company called Demotics, which I'll introduce a little bit because I'm kind of using them as a case study to explain why we're looking at the cloud and what we're looking to do. So the cloud. It's a bit of a buzzword. According to Wikipedia, cloud computing refers to the delivery of computing and storage capacity as a service to a heterogeneous community of end recipients, which doesn't actually mean much. To me, and I expect to you, the cloud really is just a buzzword to basically mean VPSs that you can set up when you want them and scale them up and down. Perhaps have an unlimited storage space as well, and maybe a CDN as well if you're lucky. I mean, the cloud, yeah, it's like 2.0 or 3.0. It's just been used by lots of different companies to mean lots of different things. Governments are now using it to talk about policy. It's crazy. So what do we care about as Drupal developers in terms of the cloud? Well, I've broken it down to three things. It's servers, storage, and delivery. Servers, and by that I mean virtual private servers. Storage, where you're going to stick your files, essentially. And delivery, using CDNs and some other clever little tricks. So you probably know the marketing spiel that comes with the cloud. You know, new servers anytime without having to provision them or anything like that. You can scale up and down the servers, sometimes without even needing to restart your VPS. You can have unlimited storage, which is crazy. You only pay for the services that you use. So if you have a load spike, you spin up new servers. If you get vastly unpopular, you spin servers down or you reduce the resources that you're using. You have short contracts or sometimes even no contracts, so you're not tied into one vendor for an extended period of time, which can be very, very useful. And finally, and possibly the most important, you have total control over your server. You get root access, you can install Drush, you can hack the heck out of it, you can do whatever you want to it. You are the master of your servers, which if you've come from a shared hosting environment or another host, sometimes you don't get that luxury. So that's the cloud in a very, very brief overview. I'm now going to give you a quick overview of Demotics, which is the company that I work for. So Demotics is a community-powered newswire, which is like Reuters or AP, but instead of having staffers, full-time people on payroll, we have a community of locals on the ground, and we're based on the principles of freedom of speech and freedom of information. We launched in 2009, and we were founded in an attic in London. Today, we're a staff of probably closer to 20 than 14, and we have people spread all around the world. We very much believe in remote working. We partly do this so that we can have 24-hour publishing coverage as the sun travels around the world. What do we do? Well, to the world's media, we offer a view from the street. We have locals taking pictures of their peers and of their friends. So we have a local point of view, we have a local's knowledge, and we have locals' access. We have more reporters in Palestine than Reuters and AP combined. Having put reporters on the ground in the location means that when a story breaks, we're normally some of the first people there. The picture you're seeing there is the Oslo bomb. We also then, that means that we can have people available for assignments. For the reporters, we offer exposure and sales. We have any sale that we make, we split 50-50 with the person who took the picture. Reporters keep all copyright, and we don't do microstock, we do proper industry rates. We have collections teams around the world and reseller networks. We have deals with all the major news organizations. We've had front pages of most of the newspapers you've probably read. Global sales network, lots of images. We have Corbis, which is one of the largest photo libraries in the world, helping us. And we have resellers all around the world. It's actually closer to 750,000 images now in our archive. We're built on open source, obviously, and use most of the big names that you would have heard of. I try and get everyone in our organization to use open source wherever possible. Sometimes I win, sometimes I lose. We believe in helping our community, and by that I mean the tech community, giving talks like this, contributing bugs, new modules, all that kind of stuff. So that's Demotics in a nutshell. It's all built on Drupal 6. And here's some of the numbers for our site. So we get over 1.5 million page views a month, and we have a very, very, very long tail of content. And what I mean by that is, outside of the top 100 pages on our site, most pages get less than probably 100 page views. But that tail goes on for miles and miles and miles and miles and miles and miles and miles, hundreds, if not hundreds of thousands, sorry, tens of thousands of different pages. When we get spikes, we get big spikes. Being a news site, if we get an exclusive, we're looking at hundreds of thousands of views in a day, if not an hour. And Varnish has saved our butt on that so many times it's not true. If you're not using Varnish yet, have a look. It's great. We got onto the front page of reddit.com, and the only reason we knew was because our cache rate went up on Varnish. It was great. We have a 14 gigabyte database, which is pretty large. We have over 1 million nodes and well over 10 million terms. So when you do things like term node joins, it gets pretty hairy. We have between 3,000 and 5,000 new nodes a day, and we have over 200 gigabytes in the files directory. Some of our folders in the files directory have over 750,000 files in one folder. Not ideal. About 80% of our traffic is unauthenticated, and we have about 6,000 active users who are uploading regularly. So what's our current setup not in the cloud? It's pretty simple, really. Dedicated single servers. One web server, which has Varnish and Apache on it. One database server with MySQL. And a utility server which runs Solr, runs Solr, Memcache, and FTP. So we have some previous cloud experience. We actually started on the cloud. The original alpha was built on the cloud. The prototype was built on the cloud, and we still use the cloud for development because it rocks. We moved off, however, because we needed better support. Our site, for reasons best known to itself, enjoyed crashing on Christian holidays. Don't know why, just did. Christmas, Easter, you name it. And the fun thing about that, obviously, is that's when a lot of people go on holiday. And so trying to get support on Easter Sunday at 3 o'clock in the morning, not so easy. And so we moved to a host that would give us very good support for that. When we did that, we moved to dedicated hardware, we noticed a significant speed improvement, and we put that mostly down to the improved disk I/O. Why are we considering going back to the cloud if it's so great on dedicated hosting? Simply speaking, spikes. The ability on the cloud to be able to add new resources, add new servers at a moment's notice, and then scale back again is very handy. As you saw previously, we had that picture of the Oslo bomb. We got that in literally within minutes of it happening. We then tweeted it, and then the entire world decided to try and to hit our servers at the same time. Varnish stayed up. Varnish did a wonderful job. Unfortunately, our firewall between us and the internet ran out of RAM. We were getting that many requests a second that the system just overloaded. It was a Cisco firewall, but I can't remember the exact specs. We then went to our traditional host and said, we need a new firewall. And they said, yeah, sure, you can do that. It'll be ready in about 6 hours, and you've got to take it for 6 months. Not ideal for a spike that's going to last 6 hours. So for single breaking news events, you need to be able to react quickly, and traditional hosting can't do that. We also have event-based spikes, things like the royal wedding, elections in various different countries, and Olympics, when we know that we're going to get a large amount of new content coming in, but it's only going to be for a period of 2 or 3 days. Again, traditional hosting has difficulty dealing with those kind of spike usages. Also, using the cloud means that we're going to have our dev, staging, and production environments all completely the same, which is great if you're doing any testing. And also just the flexibility to try out new things. And the cloud lets you do that in a very easy way. So when we first started thinking about the cloud, we had all sorts of sexy ideas in terms of what we wanted to do. Excuse my very poor diagram. If any of you went to the session earlier on in the Node 1 room that was talking about how to do basically this setup, and if you didn't, watch it again later. I'm not going to go into detail about how you set all this stuff up. But essentially, this is what we're looking at, having multiple load balancers, multiple web servers, and multiple database servers, and multiple utility servers, so that if any one of them goes down, you don't have to worry. But so why am I talking about this, and why as Drupal developers should we care about all these complicated things? Why not just pay for it to be someone else's problem? There's lots of companies now that are starting to specialize in cloud hosting, and you just pay them, and they do it. They're the ones that get woken up at 3 o'clock in the morning, and they're the ones that have to work out how to tune the kernel to make the most out of it. My general advice is if you can do that and you have the budget to do it. It'll make your life so much easier. You want to be a Drupal developer, you want to be making new and interesting applications. You don't want to be a sysadmin, you don't want to be woken up at 3 o'clock in the morning. Sometimes it's not possible. The software as a service companies, their special source, the bit that makes them different, is their configuration, it is their VCL files, it is their apache.confs. As a result, they may be cagey about giving you direct access to them, which can make debugging quite difficult. You're operating inside a black box. Thank you. I should probably turn that off. Also, to be able to get the economies of scale that these companies work with, they have to create a generic solution. Your website may not fit that generic solution, and in those situations, you're forced to basically build it yourself. But as I said, if you can make it someone else's problem, do. So when moving to the cloud and thinking about moving to the cloud, there's a number of challenges that, as we saw it, we had to overcome. The first one is just disks and where you store your data. What I've called the slice ratio, all sorts of different companies call it all sorts of different things. Essentially, it's how you buy your servers and how you scale your servers. Most cloud operators will slice a server up into equal chunks of CPU, RAM, and disk space based on the size of the server, and then sell those off. Some people call them instances, some call them nodes, there's all sorts of different names for it. So you can buy a server with 16 gigs of RAM, and when you do that, it will come with 200 gigs of hard disk and 16 CPU cores, for example. Some of them will let you add more resources. If you need more disk space, you can just bolt on more disk. If you need more CPU cores, you can bolt on more CPU cores. Not all companies do this, so if you're looking around for a cloud provider, make sure you check before you start moving. This fixed ratio obviously presents a problem if you have a lot of data and you want to create a file server, because you end up having to build a server that's got 64 gigs of RAM, 200 cores, in order to serve files, because you need it for the disk space. The other thing to consider is traditionally the cloud has poor I/O. Because it's another step away from the hardware, sometimes the disks are over SANs or across the network. If your application is particularly disk intensive, that's something you really need to check for. Challenge 2 is location. This is getting better, but obviously when the clouds first came out, they were all US companies, which as an EU-based company, we had problems with because there's laws about where you can put your user data if you're a company registered in the EU. There may even be stricter laws if you're in the medical field and things like that, where they just simply don't let you use shared resources. There's also the issue of where your users are. Whenever possible, and this goes for any sort of hosting, you want your servers to be as close to your main user base as possible because latency actually is a real problem. CDNs can help them with this, and I will talk about those a little bit later, but still, it's better to have your servers near your users if you can. Challenge number 3, and it was one of the biggest ones for us, is getting support. Most of the reason why you move to the cloud is you want this redundancy setup where you've got multiple servers in the same layer. Adding more servers can also mean adding more problems. You have more things to manage, more code to control, more deployment to worry about. And it's not just as easy as just adding new servers. There's normally a lot of configuration and stuff that goes along with that. And again, the last session about basically how to set this stuff up is well worth looking at. The other thing to be concerned about is when something goes wrong or when you're wondering about how to configure the servers, can you get any help? Some cloud operators basically give you the servers, give you the keys, and then say, right, it's now your problem. If it goes wrong, well, tough. If they do offer support, sometimes it'll be great during normal business hours, but I thoroughly recommend you try submitting a support ticket at 3 o'clock in the morning and see what they do then. And then try it on 3 o'clock in the morning on a bank holiday or Christmas Day or something like that. Because guaranteed, if your servers explode, it won't be at 9 a.m. on a Monday morning, it will be at 3 o'clock on a Sunday night. Challenge number 4. So one of the great things about cloud servers is that you get complete control. You get root on your servers. But, as to quote Spider-Man, with great power comes great responsibility. If you're becoming the sysadmin, because you all wanted to be sysadmins, right? You need to make sure that you understand what you're doing, that you make sure that the firewall rules are correct, that you're not using the default passwords or easily guessable passwords. It's a whole new can of worms that you need to be aware that you're stepping into. And also it means that you're going to be the person that gets the call at 3 o'clock in the morning if the servers explode. Or even worse, you won't get a call and you'll come in on Monday morning and find out the server's been offline all weekend. So you need to think about monitoring systems, emergency instructions, and also what you're going to do if the worst does happen and EC2 goes down for a couple of days. What then? Are you just offline for that period? Do you have a backup plan? And so I think the most important challenge is that cloud providers are not all the same. Most people, when you talk about cloud, the first thing they say is, oh, do you mean Amazon? There's lots of other people out there, and there's lots of the other people out there do things in different ways. The ratios of how they slice up their servers are different. The bandwidth allocation and how they do it. Some of them will charge you per request. Some of them will charge bandwidth per server. Some of them will allow you to pool bandwidth across all the servers that you buy with them. They have very different support packages. And surprisingly, or maybe not surprisingly, they have actually very different performance. Another thing to be concerned about is overselling. Some smaller, maybe less scrupulous cloud providers will sell more resources than they have on an individual server, and so you can have problems. The other problem is that obviously if you're on a server and Reddit moves in next door and starts taking up all the bandwidth, you're battling with them for that bandwidth. So you need to be continually monitoring where your servers are at to make sure that you're getting the optimum performance. So where do you start? With all these problems, challenges, questions, when you're looking for a cloud provider and you're thinking about moving to the cloud, where do you start? Benchmarks would be my answer. There's a talk today about a Drupal benchmark in the Omegas 8cc room at 4 o'clock, which I'm definitely going to go to. It looks quite interesting. But until then, there's a really handy website called cloudharmony.com. Essentially what Cloud Harmony have done is they have bought servers of varying sizes in cloud providers all around the world and selected a number of benchmarks. They then run these benchmarks at regular intervals and give you the results in a nice, handy graphical format. It's really useful, and it shows you some really interesting stats and some really interesting things that you may not have realized straight out the box. What I've done here is I've selected all the servers that were either in the UK or Ireland. 4 gigabytes, because that's what we were looking at for our webheads, and graphed them. This is the web performance metric. Essentially what they've done is they've benchmarked PHP, MySQL, a few other bits and bobs. They then weighted them in their own way. They go into excruciating detail on how they calculate all of this on their website, and they basically give you a number. So more is better on this graph. And as you can see, there's a big difference between the best and the worst. We'll get onto that. But what's interesting is the blue one is Amazon. The very first blue one is Amazon. So out-of-the-box performance with Amazon sucks. Obviously, that's not the case all the time. Amazon are very clever. They're a massive company. They know what they're doing. But straight out the box, if you're just getting a single 4 gig instance, you're not going to do very well on Amazon. So I went and grabbed a couple of the other ones because they're pretty graphs and I didn't have any other nice graphics in my presentation. So here's the database matrix. Disk I/O, again, it varies wildly. So here you can see, for example, the purple is rack space. The reason why theirs is much higher than everyone else's is because they don't use SANs, they use local disks. So when you buy a slice on one of their systems, you're actually getting a chunk of the local disk, which is going to be much faster than accessing it across a network. Your memory I/O, again, and CPU. So you've had a look at the benchmarks, and you've seen that there's a hosting provider that's somewhere near you that looks about right and the price looks okay. What else do you need to look at? Well, see if they've got an integrated CDN or options along those lines. See what they do in terms of storage. Whether they give you access to SANs, whether they've got something more clever like S3 or EBS, all sorts of options for storage. Support, obviously, critical. And finally, cost comes down to. Once you've identified one that you like the look of, try before you buy. A lot of places will give you a day for free, a week for free. Some of them will give you a month for free if you start to talk with their salespeople and talk about buying a lot of data. Even if you don't get stuff for free, spin up an instance. It's only going to cost you, $50 tops to set up an instance. Try to make as close to a one-to-one copy of your current site and your current setup as you can, and then test. Test, 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 and benchmark against different providers. And when I'm talking about testing, I'm not talking about A, B, and Siege. I see a lot of people testing with A, B, and Siege, which allow you to hit a single URL again and again and again and again and again and again and again, which is great for testing your caching. It's not great for testing your application. Drupal will load the page once, and either Drupal will cache it, or if you're using Varnish or anything else in front of it, then it will cache it. And all you're then testing is how fast your caching system can serve from memory. Don't do that. It's going to give you a very false indication of how your application is going to perform. Instead, I would definitely recommend replaying log files from your production environment. The two tools that I've used are HTTP perf, which is very easy to use and really quite cool, and JMeter. And what you do there is you go and grab your Apache log files or your Nginx log files, Sometimes you have to process them a bit, but you then give them to this thing and then point them at the development environment, and it will then replay all of the activity that happened on that site during that period. And with that, you can really see what will happen in an actual environment. Obviously, doing that is all well and good. Whilst you're doing that, you need to monitor what's happening. I expect, hopefully, you've got your monitoring tools already set up, things like Moonin and Cacti. If you haven't tried New Relic yet, I would recommend having a little play. Again, I think they do a 2-week free trial. It's great. It allows you to see which processes are taking more time. It allows you to see where your databases are screwing up. Really, really worth looking at. So, you think you've kind of decided what sort of servers you want to get, and you think you've probably worked out which cloud provider you want to go with. The other thing to consider is, if you're moving to a multi-webhead environment, is what you can do with your files directory. Demotics, as we saw from the original numbers, we have over 200 gigabytes of data that we need to store in our files directory, which is pretty big. That kind of means that we can't store an individual copy of that on each of our webheads unless we wanted to have webheads that had 64 gigs of RAM with the slice ratio that most places offer. You also, as the previous session explained, you need to make sure that all of your webheads can access the same set of files, and that brings its own set of problems. When you start getting to big sites with lots and lots of data and lots of files, unless you've been very clever at the start in terms of setting up your image cache directories and your file upload directories, you will very rapidly approach a point where you have more than 10,000 files in an individual folder. This itself, just that itself starts to become an issue when you start doing LSs, and then when you start wanting to move copy files around. Linux doesn't particularly like it when you start going over 10, maybe 100,000 files in one folder. So how do we fix these problems? The traditional way to do it is well, actually, preface that. There's a really good post on this, which is by the guys at McFadyen, where they're talking about their new Valhalla file system, where they've tried to address these problems. I thoroughly recommend you read that post. I would love to be using Valhalla. Unfortunately, they haven't open sourced it, so we can't, unless you go and use their service. But that's well worth having a look at. So traditionally, the way that you solved the multi-webhead environment with a large files folder was used NFS. So you create a dedicated file server, use whatever you need to put lots of data onto that, whether it's a SAN, whether it's block level storage like EBS, whatever else. And you then expose that through NFS to your webheads. It's tried, it's tested, it's not particularly exciting, and it's also a single point of failure. So if that goes down, you're screwed. And as I said, if you're in a situation where you can't just add more data to a server, you're going to end up building a massive, very powerful server just to serve files, which you don't want to do. One very interesting potential solution to this problem is the API storage. So CloudFuse, sorry, no, it's Cloud Files, not CloudFuse, and S3. Essentially, they give you an addressable storage that's pretty much unlimited. You get buckets, you just stick stuff into it and pull it out, and they worry about replication and redundancy and all that kind of stuff. Theoretically, you get unlimited storage with that. There are limits, and once you start reaching over 1 million files in some buckets, performance will start to degrade. But realistically, it's pretty much unlimited for most Drupal sites. With a lot of them, you'll also get CDNs with little or no extra effort. You can just tick a box and say, I want this bucket to, as well as being a data store, I also want it to be a CDN, which is great. You get a CDN into the bundle. It's a bit bleeding edge and untested. Essentially, the solution that I'm talking about there is using a Fuse library to mount this API storage as a file system, which then means that Drupal can access it in the way that it normally would. You've got nothing complicated going on there, and you get this unlimited storage at the back end. It's potentially really, really quite cool. The other solution is GlusterFS, which again, I expect will be spoken about numerous times. It seems to be flavor of the month at the moment. It's a very impressive solution. The previous blog post talks about some of the trade-offs that it makes. It may or may not be right for you. It's more complicated setup than NFS, but it's likely worth the effort. So that's storage. Assuming you've got that all sorted, what about CDNs? I'm assuming you all know what CDNs are. For those of you that don't, it stands for content, from mind's gone blank. Content distribution network. Essentially what it means is that you have servers dotted around the world that are much closer to your end user. So instead of your users having to request a file from you all the way over in London, if they're in Sao Paulo, they can go to a server just in Sao Paulo to receive image assets. It speeds the page up massively. As you can see here, this was a test from our dev server that I did a little while ago, which is based in Paris. So from Germany, it takes two and a little bit seconds to load the page. From South Africa, it takes 12 seconds to load the page. Ignore the fact that some of the files are different, file sizes are different. Don't know why that happened, but hey. But essentially what I'm showing you here is that it is a big difference. You know, you can tune your site as much as you like, but if the person's on the other side of the world, it's still going to be slow. The tool that I use to use this is the URLs along the bottom. They've got servers all around the world, so you can test how it works all over the place, and I recommend having a look at that. So there's multiple ways you can solve the CDN problem, and Wim Leers does a good discussion of that. He's also the author of the CDN module, so he knows what he's talking about, and if you're doing CDN stuff, you're probably going to be using the CDN module. So there's kind of three. I'm not really sure about the third one, but the first two are pretty well established. So you have push CDNs. This basically means that you send your files off to these remote servers and then point to them instead of pointing to your local files. It can be quite complicated to set up. You end up having to use a thing called a file conveyor, which can be tricky. And it can just be painful, basically. The big ones that you're going to be looking at with that are Cloud Files and Amazon. CDN pull. This is by far the easiest solution. There's lots of different companies that provide them at varying different cost levels and varying different points around the world. Essentially, you just change the URL that you're addressing. So instead of saying www.domotics.com/favicon, you could say cdn1.domotics.com/favicon. That points off to a different server, which will be local to the person. If they don't have a local cached copy, it comes back to www, pulls it back, and then stores it locally to be then replayed. Very, very easy to set up. CDN module makes it very, very easy. And you get a very easy win for relatively little effort. The final one is what I've called DNS CDNs. They're relatively new. The two main ones that I've seen are called Cloudflare and Capsula. Essentially, you hand over your DNS to these providers, and they do all sorts of magic, essentially. They sit in front of all of your requests. They'll give you analytics on the front. They'll optimize your page. They'll compress it. They'll optimize your images. They'll protect you against bot attacks. And they'll also cache your content locally around the world so it's faster for your users. We've looked at it. We haven't really tested it or played with it yet. I was a little concerned about handing over my DNS to a third party. But it may be a good solution for you, and it's certainly something you might want to look at. So a quick roundup of some of the conclusions that we had when we were looking at whether the cloud could come to our rescue. Firstly, the cloud isn't a magic bullet. It's not going to solve all your problems, and even if it does, it's not even a particularly well-defined concept. It's a word that's used to define lots of different things. The individual cloud providers themselves differ a hell of a lot. They all kind of have a different take on how they're going to do it, and as a result, the performance and the way that your application may run on their servers can differ wildly. You can use benchmarking to try and help you differentiate those providers and work out which one might be right for you. But bottom line, the best benchmark is going to be your own application, because you can't really tell until you're using your own application on those servers. Storage can be complicated, or it can be quite simple. And CDNs can give you a very easy win that will benefit users all around the world. So what did Domotics do? So yes, we are going to be moving back to the cloud. Hooray! But it's taking longer than we expected because we were far too ambitious and we changed far too much at the beginning. We didn't do what I recommended, which is making a one-for-one copy. We kind of got all excited in the sweet shop and said, let's use Nginx, let's use MariaDB, let's change how we're doing everything, which makes debugging pretty tricky. So that's extended our testing phase quite a bit. We picked a cloud hosting provider based on some of the benchmarks that we saw. And as one of you pointed out, yes, who's the red one? Red one is a company called DediServe. And there's my shameless affiliate ID if any of you do want to try it and sign up. And they do give a month free, I think, or maybe it's only a week. But yeah, you can go and play. Like I said, we're still retuning some of the bits because we changed too much. We were looking at using PHP FPM, and maybe mod PHP is better for us. But hopefully, touch large quantities of wood will be live sometime next week. what do we do for storage? So given the nature of our business, we couldn't really mess around with trying bleeding edge stuff. I didn't want to be that guy. So we're using an NFS-based solution. Our provider actually offers that as a service, and so we can say we just want 200 gig, 300 gig, 400 gig of NFS storage. Just give me the URL, the command to connect to it. We then mount that on the webheads, and it works pretty well. We are still very much interested in Gluster. There are intricacies that cause a problem for us, given the sheer volume of data that we have. When you spin up a new Gluster node, it has to sync all the data across. And so if we spun up 3 new nodes, you're talking about almost a terabyte of data going across your network, which will kill any other servers using the network. CDN, yes, we use CDN pull. It was very easy to set up. It was a pretty much instant win for our users all around the world. And also, again, the CDN module gives you this great option of setting up multiple CDN URLs. So you have CDN1.demotic, CDN2, 3, 4. And what that means is your assets are then on a single page load are spread across multiple subdomains, which is a front-end performance trick. And again, you get it for free. No effort, no work. It just happens, and it can knock seconds off your page load time if you have a lot of assets on your page. So what's our actual cloud setup going to most likely look like? It's going to look something like this. We're going to have a load balancer on the front, multiple web servers, a single big-ass database server, probably with a hot spare, and a single utility server. We're going to have the clouds off to the side in an NFS share, and we're going to be using our CDN. So two of the other things that I touched on very briefly. One of them is this problem of when you start to scale to a large scale site with lots and loads and lots of images in a single directory. How do you deal with that? One very easy way to do it is obviously put the date in the file path, and then you're done. Unless you're getting more than 10,000 or 100,000 nodes in a single day or images in a single day, you should probably be all right. We didn't do that. The solution that we've ended up going for is a little bit more complicated, but it works for us. Essentially, we wrote a custom Drupal 6 module which looks at the file name, and then from the file name builds a token based on that file name. All of our file names are numeric, so it made our token creation very easy. We just chopped it to the nearest 1,000, and that was the bold name. In D6, it's kind of tricky because you can't hook into the file save hook at the right point, so it actually gets written to disk first and then rewritten to disk, which is less than ideal, but it's a working solution. It'll be on Drupal.org very soon, but it's still pretty alpha. The other thing that we looked at and we actually got working was using the CloudFuse solution with the CDN and using lots of files. So mounting, as we saw before, API storage and then using that as a CDN solution. It does work. Surprisingly, the I/O impact isn't actually that significant, mostly because Drupal reads files a lot rather than writing them. And in most of those situations, you're using a CDN to serve the file, or it's cached in Varnish. So you're pretty much good. There's a few other little modules that will help with that. There's one called image info cache, which stops you hitting the files repeatedly. The problem with that solution is it requires you to pre-generate all of your image cache settings, because obviously if you're hitting a remote URL for image cache, the files already need to be there. You can't use the standard image cache menu books. It's not published yet, but if anyone is interested in that, I'll happily share the source code. Some other things that we found out that made our life much, much easier when we were thinking about moving to the cloud, one of them is Puppet, or any other build automation. You can use whatever you like, but it made spinning up new servers on different clouds really, really painless and almost fun. And it's also great if you're going to have local developers doing stuff. It just means that you can spin up an instance with little or no effort. Two other little things which aren't really strictly related to this talk, but we found them, and when I've told people about them, they found them really useful. One of them, the URL alias table, can be quite slow with InnoDB. Not quite sure why, but essentially some of the conditions when you do a URL alias lookup, it checks for the language. If you don't have a multi-language site, that's pretty much redundant, and if you remove it, it increases the speed with an InnoDB lookup. MySam doesn't seem to care, but InnoDB, it slows it down by a factor of about 10 compared to InnoDB, when you've got big, big tables, this is. The other one, and is a ridiculously easy win, if you have a big site that has lots of taxonomy terms, check the description field in the term data's table. In core, I think certainly in 6, not sure about 7 or 8, the description field is a text field. MySQL will not use in-memory tables if you have a text field in the query. That means that it's writing those tables to disk when it's doing sorts and joins. This is incredibly slow and will kill performance. If instead you change it to a varchar 255, which 9 times out of 10 doesn't make the blindest bit of difference to the actual site because no one uses the term data description field anyway, we saw our database load drop by half. It was huge. So yeah, that's definitely worth checking. There's all sorts of things I haven't talked about in this: backup, disaster recovery, all sorts of other stuff. There's probably all sorts of other things I've missed too. But I wanted to kind of give you a basic overview of what we thought when we were looking to move to the cloud, the processes that we looked at, how we decided which cloud operator we're going with, and the sorts of challenges that you're going to be looking at facing when you're moving to the cloud. So that was it. I'm probably massively under, but if there's any questions, I'd love to hear them. Do you want to take the mic? I don't know if that's on. Yep. The InnoDB one for URL alias, no. The one for the text into varchar, yes. It's known about, but just no one seems to know about it. Indeed. So again, that kind of goes back to the disk thing and testing your application. Some service providers, I sound like an advert for our current one at the moment, they let you select which, it's over SAN, but they will let you select what kind of disks you want to be backing the SAN. So yes, for our MySQL database, yeah, we use SSDs. Any other questions? Yes, we'd love to, but we have somewhere in the region of 100 custom modules. So moving to 7 is going to take a while. We're probably going to skip 7 and jump straight to 8 and probably rewrite in the process, is our current idea. Yeah, so no, not at the moment. I would love to, but yeah, not quite. Cool. Well, if there's no other questions, thank you very much for listening. I hope it was useful and interesting. I'm on Twitter, Facebook, all that kind of stuff. Message me if you've got any further questions or come and have a chat afterwards. And yeah, you might be able to go get some lunch. Thank you.